Hi, and welcome to lesson 5. Here we're talking about the distributive property. So what can we do today? We can use the distributive property, and with that we can combine like terms. So use the distributive property to simplify the following expressions. So if I have something like this, the distributive property is, so if I have a number sitting outside of the parentheses, notice that there's no operation sitting there. It's implied that if it's just sitting next to the parentheses or a variable like that, that it's multiplication. So now, what this means right here is if I have 2 times the quantity x plus 4, what I can do is I can take this 2 right here and I can distribute it through the parentheses. Now, the operation that is going on between that is multiplication. So you've got 2 times x. 2 times x is a 2x, and you've got 2 times a positive 4, which is going to end up being 8. So 2 times x and 2 times 4. So if I was to write this out, it would say 2 times x plus 2 times 4, which 2 times x is going to be that 2x, and then 2 times 4 we can simplify down to 8. So it's going to be my 2x plus 8. Same thing here. Use the distributive property to simplify the following expressions. So I have 6, I have 3 minus a. Now, the number that gets multiplied through the parentheses is going to be that 6. So it's going to be like saying 6 times 3 and 6 times plus 6 times negative a. Now, with this, you want to take on the sign. So we've got a 6 times a negative a. We'll get to that in just a second. So we've got a 6 times 3 is 18. Now, we've got a 6 times a negative a. It's a positive times a negative. So this is going to end up being a negative 6a. So it's going to be 18 minus 6a. So if I just looked at this, if we back up, and I just looked at this and I used kind of my little circle property here, we're taking that 6 and we're going to multiply it by 3. That's going to give me 18. And then if I've got my 6 and I'm going to multiply it by negative a, it's going to be a negative 6a. So that's what I'm looking at when I'm doing this. So it's going to be 18 minus 6a. So it's going to be that second one, it looks like there. Use the distributive property to simplify the following expressions. One more. We're looking at this. Notice it's a negative 3 outside the parentheses now. So when I take this, I'm going to multiply negative 3 by both of those things on the inside. And in this case, we're taking that negative 3 times 2. A negative times a positive is going to be a negative 6. And I've got a negative 3 times a positive x. So it's going to be a minus 3x. So negative 6 minus 3x is going to be my simplified version of this expression. So negative 6 minus 3x. Notice the sign goes with it, and the sign affects the sign of those things there. Here you got something, you got the number. Notice it's behind the binomial, this is called, because there's 2 terms inside there. It's going to be the same thing. You can take this negative 2 and you can multiply it by each of the things on the inside. So really it's the same as if you had the negative 2 out front. It's just this negative 2 is going to get multiplied through the parentheses. So negative 2 times m would be a negative 2m. And then a negative 2 times a negative 5. And here we've got a negative times a negative. So negative 2 times negative 5 is going to end up being a positive 10. So it's going to end up being negative 2m plus 10. Negative 2m plus 10 is going to be that one. Here we're looking, and we've got m. Ooh, that doesn't come up very nicely. We've got m times m minus 7. And this is going to be a little bit of a preview for tomorrow. We're going to multiply each number by the m. And if I had m times m, that's going to give me m squared. And if I had m times negative 7, that's going to be negative 7m. So my answer would be m squared minus 7m. Notice an m squared is not the same as an m, and that's like terms. We'll talk about those in just a second. Use the distributive property to simplify the following expressions. This is going to be similar to the one we just did, except notice your number that you're going to multiply is on that side. So if I had f plus 9, and I'm multiplying my f through the parentheses, it's going to end up going, that doesn't show, oh yeah, it's okay. F times f would be f squared, and it's going to be f times positive 9, which would be like saying 9f plus 9f. So there you go. So f squared plus 9f is going to go right there. Now, a couple definitions that we want to talk about. Like terms, we'll start with like terms. These are going to be terms that have the same variables and powers. So if I had something up here where if I had 7x and I was adding 4x, notice the same variables and the same powers. It's x to the first, it's x to the first. So if I had 7 x's and I added 4 more x's, how many total x's would I have? I would have 11 x's. So I've got 11 x's here. Okay, notice that the x doesn't change. If this was a situation where I had 8 y's and I added 3 w's, are those like terms? No, they're not. They have different variable powers, so we can't combine those. Only, even if I had 8 y's and I had 8 y squareds, could I combine those? No, they're not the same. They have different powers. They're the same variable, but they're at different powers. So what we have here is like terms, variables, and the powers are the same. Coefficients now. Coefficients are going to be the quantities that multiply the variables. So if you're looking at something like this, if I had 12m, the coefficient is going to be 12. So the coefficient is going to be 12. If I had negative 3x squared, the coefficient is going to be negative 3. It's the number sitting out front of the variables. It's what you're multiplying by. Constants, these are going to be terms that have a fixed value. They contain no variables. They're just terms, they're numbers, they don't have any variables. So if I had 8x plus 3, my constant in this situation would be 3. This is a variable term. 8 is the coefficient. These are not like terms. Plus 3 is the constant, because this is not going to be affected. That term right there is not going to be affected by any variables and anything that gets plugged in. It's always going to be a plus 3. So identifying. Are the underlined portions of the following expressions like terms, constants, or coefficients? If I've got 7x and I've got a positive 3x there, those aren't constants. We know that. We know that they're not coefficients. We know that they're like terms. Remember, if it was coefficients, it would just be the 7 and the 3. If it was constants, there wouldn't be the variable there. Are the underlined portions of the following expressions like terms, constants, or coefficients? Well, there's no variables there, so we know that they're not. Coefficients. Okay. Technically, they could be like terms, but we know that they're constants. We know that they're constants, and there's no variables there. Like terms, we'll say implies with the presence of the variable there. For the sake of doing this, we know that those are constants. Are the underlined portions of the following expressions like terms, constants, or coefficients? Now notice, and I know it's a little bit blurry here, you're only focusing in on the positive 2. You're only focusing in on the positive 14. So those right there, they're not like terms because we're only looking at the front part. They're not constants because there's variables there. These are coefficients. So what can you do with like terms? Notice if you've got the same variable expression here, you can combine like terms. So if I had negative 9y's and I added a negative, which is the same as subtracting. So if I subtracted off another 2y's, I'm going to land on, I'm at negative 9. I'm going to count down 2 more. I'm going to be at negative 11y. So my answer here would be negative 11y. Because I had negative 9, I go down another 2. I'm at negative 11y. Something like this, same story. Just go about your business here, and we'll find out how many J's we have. We've got 2.9 J's here, and I'm adding 4.6 J's. So to find out how many J's you have, you add the coefficients, and we can use a calculator. If I've got 2.9 and I add 4.6, I know that I have 7.5 of these J's. So I have 7.5 J's. Okay, notice we can add the coefficients because the variable terms are the same, and then we can just we can write it with that variable factor there because we got 2.9 J's and we had 4.6 J's, giving us 7.5 J's. If you think about it as dollars, if I had $2.9 and I added another $4.6, I would have $7.5. I wouldn't have dollars squares or double dollars. I would have $7.5. That's what we're working with there. Last piece of the puzzle. So simplify the following expression. So the distributive property is going to lead to some combining of like terms that we have here. So notice what's going on. We've got a 4 sitting outside the parentheses. So we're going to want to multiply that through. We'll simplify it out, and then we'll combine our like terms, and we'll land on hopefully a nice clean expression. So we're going to start here, and we are going to multiply that 4 through the parentheses. 4 times 5 is 20. 4 times negative 2i is going to be negative 8i. I've got a minus 21. Notice this 4 doesn't go anywhere outside of those parentheses. Minus 21, and I'm going to plus 7 i's. So let's look at our like terms. I've got negative 8 i's. Oh, come on. I've got negative 8 i's here, and I'm going to add 7 i's. So if you're 8 feet underwater and you swim up 7 feet, you are going to be 1 foot below. Now, a negative 1 is a coefficient that you don't necessarily have to write that 1 there, it's implied. So let's look at our 20. I've got 20, and I'm going to subtract 21, so it's going to be minus 1, leaving me with a negative I minus 1. Now look up here at your answers here. They're shuffling things around because they have their 1 first or their negative 1 first, and that's okay. We just need to change the order here. So we'll say that the negative 1 minus I. Now, is that an option? Negative 1 minus I. Yep. Your terms, you've got a negative I, you've got a negative 1. You can rearrange those as you need to. Last one, simplify the following expressions. Let's rewrite it. I've got 5, I've got m minus 3, I've got plus 17, I've got minus 4m. So we're going to start with the distributive property, and we're going to clean that up. So let's take this 5 and multiply it through the parentheses. 5m minus 5 times negative 3 is going to be negative 15, plus 17 minus 4m's. So let's start here, and let's look at 5m's and negative 4m's. If I had 5m's and I subtracted 4m's, you had $5 and you spent 4, you would be left with a single m. Now here, that doesn't show up very well. Here I've got negative 15, and I'm going to add 17. Negative 15, right? The sign in front of it tells you the sign of the number. So negative 15 plus 17 is going to send me up to positive 2. So now I have m, or a single m, plus 2. And is that one of my answers? Yes, it is. So there is the distributive property with like terms, coefficients, and constants, and then combining like terms to come up with simplified versions of expressions.